This is part 2 of Algebra B's study guide for test 5 of quarter 2. So let's take a look at the sixth problem we'll see on the test. And this one is testing you on whether you understand the rule of outside exponents. So the first thing we need to remember is that this is all in parentheses. That means everything is being brought to the third power. If we wanted to, we could rewrite what is inside the parentheses exactly as it's written. Negative 4a to the third, c to the negative second. We could write that 3 times and then multiply everything. Well, since we'd be rewriting it 3 times, that means we have 3 groups of everything. So what we can do is we can use the rule of multiplication. When we have repeating addition, we can multiply. And that's what we're going to do here. So the key is making sure that you have an exponent on each of the numbers, because the rule is that we're going to multiply exponents. So I put a 1 here for the exponent of negative 4. So I'm thinking of this as negative 4 to that first power, and I'm going to multiply the exponents. Now the common mistake is people are going to multiply 3 times negative 4 and get negative 12, but as you see, that's not the right answer. So what we have here, again, I'm showing you negative 4 is being brought to the third power because I'm going to multiply those exponents. And then I'm bringing this a, that's already the third power, I'm multiplying the exponents because it'll become a to the ninth. And then c to the negative second is being multiplied 3 times, as that's what that outside exponent says. So that'll end up making negative 6. So we go ahead and do the work there. We've got negative 4 in parentheses to the third power because it's negative 4 being multiplied 3 times, not positive 4 being multiplied by 3 times and then times by the negative 1. It's negative 4 being multiplied 3 times. And then a to the ninth and a c to the negative sixth. So what we can do from here is just simplify a little bit by taking any negative exponents and just switching their location in a fraction, because that's what negative exponents represent. It's just the same number, except it's the reciprocal of those positive exponents. So when we rewrite this, it's going to be, I'm going to go ahead and multiply out these 4s, so that makes negative 64. Negative 4 times negative 4 times negative 4 makes 3 negatives, so it's a negative, and then 64. A to the ninth, but then down below, we write down c to the sixth power, because we have positive exponents when we switch their location in the fraction. So the next problem is testing you on the same thing, but just a little bit harder, because now we've got 2 of those problems, plus we're going to end up having to collect some terms with the same bases. So again, the first step is always to put exponents on coefficients and variables that don't have exponents. So that's the first step. Then what we do is we multiply. We're going to take that negative 3, multiply it by the exponents, not by the numbers, but by the exponents. And so when we do that, we go ahead and rewrite what we've got. It's 5 to the negative third, so I'm going to go ahead and just multiply the exponents here. So I'm going to skip this secondary step. So you just have to follow along. X to the negative sixth, again I did negative 3 times 2, made negative 6. And then y to the negative third power. So 1 times negative 3 makes negative 3. Do the same thing on this part. 2 to the second power. 1 times 2 makes 2. And then x to the negative 8, because the negative 4 times 2 makes negative 8. And then y to the negative fourth, because negative 2 times 2 makes negative 4. So from this point, we can go ahead and collect some terms at the same basis. So no common base with the 5, so I'm just going to rewrite that. But I'm going to bring the other coefficient, 2, next to it. Now, again, I could go ahead and multiply out those 2's, but I'll just leave it in the exponent form for now. And now take the x's. So notice that here we have the common base, x to the negative 6th, and I have a x to the negative 8th. I'm going to combine those. Now, the rule is you add exponents when things are being multiplied. When terms are being multiplied, that's what we do, add the exponents. Now take the y. So we have y to the negative third, and we have a y to the negative fourth. And so we can add the exponents up. They have the same base of y, so we can add the exponents. And then we just go ahead and see what we've got left over. So we still have this 5 to the negative third. We have a 2 to the second. We have now an x to the negative 14th and a y to the negative 7th. So what we can do from this point is treat this as a fraction and take any negative exponents, those negative exponents like the 5 to the negative third, the x to the negative 14th, and also this y to the negative 7th, and all we're going to do is just switch their location in the fraction. Then the exponents become positive. So if I do that, I still have that 2 to the second up top, and I got the 5 to the third now on the bottom, x to the 14th, and a y to the 7th. Now you're not going to get full credit from me if you leave your answer this way. These numbers can be multiplied. They're not that big, so let's go ahead and do that. 2 squared makes 4. 5 to the third, so that's 5 times 5 times 5. So that's not 15, it's 125. So make sure you multiply out the numbers. 5 and 5 make 25, times another 5 makes 125. X to the 14th, and a y to the 7th. And there is our answer. So that answer there would get you full credit. Well, the next problem is testing you on what do you do when you're dividing. So the common mistake here is that people are going to end up messing up on the coefficient, or the exponent on the a term, and the coefficient. Most of the time the mistake is that they don't reduce the fraction. You have to reduce, this is a 15 over 35. It's just being multiplied by a to the 4th over a to the 7th, being multiplied by c to the 2nd over c to the 6th. We just wrote it as one fraction. So don't subtract these numbers. Reduce the fraction. Take out the common factor. That's what you're going to have to do on your problem. So when we do that, I now have, on the top, I have a 3. When I divide that by 5, that 15 by 5, 35 over 5 makes 7. Now whenever I've got the negative exponents and I'm dealing with a fraction, I don't use the rule of subtracting. I think I'll make more errors if I do that. I'm just moving exponents when they're negative. So if they're negative on the bottom, I just move them to the top. And then I think of the rule. And so really I've got an a to the 7th on the bottom. That was originally there, and now I've had an a to the 4th. So you notice I don't do the rule of subtraction like the book shows, negative 4 minus 7, and then if it's negative, you move the fraction back to the other side. I initially move the fraction, if it's negative, to the other side, then I collect. Now, here we have a case where we have the same base, c, and we don't have the negative exponents. So I'm going to go ahead and just cancel out the 2 c's on top. So those 2 c's are going to cancel out, and then take away 2 c's from the bottom, and that leaves me with 4. So when the negative exponents are in the fraction, I make them positive. But if there are no negative exponents, I just go ahead and follow the rule, which is subtract the exponents and look to see where they're at. See, there's more c's on the bottom. That's why we have the c to the 4th left on the bottom of the fraction. Now I just collect those two terms together with the common base and rewrite my answer. So I still have the 3 on top. We still have a 7 on the bottom, but now we have 11 a's on the bottom. 7 and 4 make 11, and c to the 4th power. And there is our answer. So the last problem combines that concept of division, but then also with the outside exponents. So let's see what we do. What I'm going to try doing here is I'm going to take any outside exponents and clear them, and any inner exponents and reduce the fraction to make it easier. So first thing, take that negative 2 and multiply it by those exponents on the 3 and the 5, which are both 1. So it becomes 3 to the negative 2nd, 5 to the negative 2nd. Get that negative sign in there. And now, instead of multiplying the exponents initially, I'm going to get rid of this inside exponent. So I'm going to do some reducing here, and I'll leave this as d to the 4th. But down below, I've got some extra work to do. You see, we have an outer exponent here. So treat that as e to the 1st, and then multiply those exponents. Let's see what we get. So when we do that, we now have d to the 8th power, and I have an e to the 4th power, but I still have not removed this 3rd power. So the mistake people are going to make is not being careful about bringing things down that they haven't dealt with yet, like this outside exponent of 3. So before I even multiply the exponents, I'm going to reduce. See, d to the 4th can cancel out 4 d's here and leave me just with 4 left over. So let's go ahead and rewrite what we've got now. But before I just rewrite it, let's take a look at this fraction here. So I've got negative exponents. Let's just switch the location right now to make them positive. So we'll go ahead and do that. So now I have a 5 to the second on top. I've got a 3 to the second on the bottom. So I just switched the exponents that way, or I switched the terms on the other side of the fraction, took their reciprocal, and that way I don't have to deal with the negative exponents. Now, when everything cancels out on top, you're left with 1. So I have 1 on top, d to the 4th, and an e to the 4th on the bottom. And this is still all to the 3rd power. So what we can do from this point is go ahead and get rid of this outside exponent. Remember, if you don't see an exponent, it's 1. And then multiply all those exponents. And so now we still have this 5 to the second, which I could go ahead and multiply out now. Makes 25. And then the 3 squared makes 9. And then I'll go ahead and rewrite what we've got here. We've got 1 to the 3rd. I've got a d to the 12th now, and an e to the 12th. Well, 1 to the 3rd just makes 1, so I don't need to worry about that. 1 times 25 is just 25, so we can now just rewrite this as one fraction. 25 over 9 d to the 12th, e to the 12th. And there's our answer. So again, the common mistakes are people think that these negative exponents represent negative numbers, like they'd say negative 9, negative 25. That's not the case. Negative exponents just mean take the reciprocal and they become positive. They're just fractions of numbers, and that's all. So this test is mainly on exponent rules and then also graphing inequalities, systems of inequalities, that is. Good luck.